We take this opportunity to thank IICDC and Texas Instrument on behalf of our mentor and institution for providing this overwhelmed opportunity in spite of COVID-19 pandemic. Our project title is Updates in Software, Why Not in Hardware? We kindly inform you that we had submitted the part 1 video in the first intern submission. In this video, we stated the phase 2 progress of the project. We have retrieved the signal from the sensor. In this phase, we had concentrated in extracting the output result by implementing machine learning algorithm and projected the progress for the next phase of the project. Synopsis: Emendation of Phase 1, Progress of the project, Progress on Phase 2, Conclusion. Emendation on Phase 1. The main aim of our project is to read the road condition with the help of sensors like accelerometric sensor and feeding the signal from the sensor to machine learning algorithm like k-means machine learning algorithm. In phase 1, we have retrieved the signal of accelerometer sensor ADXL335 from Beagle-Born Black microcontroller for detecting the condition of the road. We used k-means machine learning algorithm for analyzing the abnormal points. Progress on phase 1. In phase 1 of the project, we retrieved the signal and analyzed the abnormal points. In this phase, we have constructed the k-means machine learning algorithm with the collective set of trained data. Trained data is a set of data retrieved from the sensor for n number of days. Collective set of trained data from n number of days will denote the abnormal points. For instance, the abnormal points may be humps and dumps on the road. As we stated earlier, the road condition can be read and monitored with these procedures. Progress on phase 2. K-means machine learning algorithm. K-means clustering is an unsupervised learning algorithm. There is no label data for this clustering, unlike in supervised learning. It performs the division of objects into clusters that share similarities and are dissimilar to the objects belonging to another cluster. In our project, we implemented k-means machine learning algorithm by using the RStudio. In data science, RStudio is used to handle the huge data set. It makes graphics much more accessible for casual users. Since the k-means is an unsupervised learning, it can adapt easily to the environment. It is simple to implement. It can handle the large number of data sets. If the variables are huge, k-means most of the time computationally faster than the hierarchical clustering. K-means produce tighter cluster than hierarchical clustering, especially if the clusters are globular. The main advantage of using the k-means clustering is that it has a automatic recovery from failure. That is, recovery without the human intervention. We have implemented the k-means algorithm in the RStudio. In our project, first we imported all the necessary libraries. Second, we imported the dataset from the cloud. Third, using the elbow method, we found the optimal number of clusters, and we have also plotted the graph to visualize the elbow method to find optimal number of clusters. Finally, we applied the k-means machine learning algorithm and we visualized the clusters. This project the output. Due to this pandemic situation, we were not able to extract the on-road dataset by fixing the sensor in the car. Day 1. The model is constructed from the dataset retrieved from the sensor on day 1. Day 2. The model constructed from the dataset retrieved from the accelerometric sensor on day 2. Day 3. The elbow method and the cluster formation from the day 3 dataset. These are the datasets from day 1, day 2, day 3. Test data in our case is that every car companies have its own driving condition to attain the maximum mileage. The driving term provided by the company will be the test data in our project, which is yet to fit along with the trained data into the control adaptability system. In control adaptability system, there are many different functions programmed or embedded to this system, such as cruise control and control adaptive braking system. In our project, we focus on cruise control and control adaptive braking system for providing the better fuel efficiency. Primarily, we progress it on the control adaptability, electronic control unit of any company's car. References. This picture projects the structural design of the accelerometric sensor to be placed on the suspension system in the car. Thank you.